A SpiderHarp is a scaled-up version of a classical spider's orb web. We were inspired to make the SpiderHarp because we were already looking as a scientific project at understanding how spiders' senses worked, how the vibrations traveling through the web, what kind of patterns spiders would be looking for in order to understand on the biological end how their senses work. At the same time, we realized, hey, if we've already built a large-scale model so we can investigate this, and our implementation of what we think the spiders are doing is so good that we can tell you which string is being plucked on the web, then this sets it up very nicely for an instrument. And the scale was already about the size of a harp, so it lent itself very naturally to being turned into a musical instrument.
I'm Chet Udell, and I'm an assistant professor in biological and ecological engineering, and I also direct the OPENS Lab. It stands for Openly Published Environmental Sensing. I'm a second-year professor here, and so my first year I came in and I saw this special on the BBC about this wild robot spider that can detect position of vibrations on a web. I'm always looking for new ways I can create musical instruments. Yeah, we met up and I was like, you know, your robot spider would make a really great harp. And he's like, yeah, this would make a really great harp. So we decided to collaborate. Vibrations are sound, and so we're using accelerometers to translate those vibrations into fluctuations in data. That data enables us to analyze that sound, and so we're just basically translating sound into a program that lets us analyze it in a computer and then figure out all kinds of stuff about where those vibrations are coming from.
So day to day, I think in the early stages, a lot of it was designing the stand for the web, getting all that figured out. And then we spent quite a bit of time picking the right web, which turned out to be an important thing for having this be accurate to a state that you can actually play it like an instrument. So in the robotics arena, I think there's a strong opportunity for a lot of interesting art collaborations. And it's great because the discussion kind of tends to be more centered around the science behind making it work and things like that. So it gets people talking about, you know, what the efforts were involved in getting it to work, not just looking at it as a performance. It's just been a really fun project because there's a lot of different things interacting. So it's pulling in a lot of things from engineering, from biology, and now also music and art.
Collaboration at Oregon State is very easy. There'd be no barriers at all. Chet and I were able to set up a collaboration. We were just able to say, hey, we've got some space and some resources for the project, and Chet has a vision of where we can take the project, and we were able to work right there.
I think that you'll often find innovation and new things where people are having the most fun. And for me, it's in this intersection of music, engineering, computer science, and real-time artistic performance.